Medical Congo 2021. This will be the physics part. Question 1. The answer is B, and this is the solution. From the diagram that follows below, it can be seen that between two opposite charges, there exists no point between A and B where the electric field point is 0. This point exists only outside of the line segment AB, but towards A because the minus 6 picocoulomb has a lesser magnitude than the plus 6 megacoulomb. Hence, in the figure below, that point is to the right of the green charge, as you will see below. And you should take note that for like charges of different magnitudes, the point of new electric field strength exists inside the line segment joining them and towards the lesser magnitude charge. So this is the diagram here. So there exists no point between A and B if the charges have unlike polarity. So the electric field point is 0 only outside AB and near the lesser magnitude charge. So the answer is B. Question 2. The answer is still B. We see that from the equation charge equal to electric current times time, we have I, which is the current, being equal to Q on T. So I equal to 24,100 divided by 40 times 60. 40 minutes being converted to 60 seconds gives us that. So I is equal to 10.04 amperes, which is approximate to 10 amperes. Also, for note, we can have that from Ohm's law, V is equal to IR, where V is the voltage, I the current, and R the resistance. And Joule's heating, E is equal to IVT, where E is the electric energy. So question 3, the answer is D. And that's the diagram there. So you have an electric motor which is supplied by a potential difference of 220 volts. A current of 10 amperes passes through the 2 ohm electric motor. So from Ohm's law, we have the PD through the motor, Vm is equal to the current through the motor, which is Im, times the resistance of the motor. So the PD through the motor will be given by 2 times 10, which is equal to 20 volt. Hence, the power, which is equal to the current through the motor times the potential difference to the motor, will be equal to 10 times 20, which gives us 200 watts. So our mechanical power is 200 watts. That gives us our answer D. Question 4. Our answer is C. From Coulomb's law of electrostatics, which states that the electrostatic force of attraction or repulsion between two charges is directly proportional to the product of their charges and inversely proportional to the square of their separation. Hence, we have that the intensity of the electrostatic force is equal to the K times Q1 Q2 divided by R square. The K here is a constant, which is 9 times 10 to the 9 SI units. Q1 and Q2 are the respective charges, and R is the separation between the two charges. That's Q1 and Q2, that is K, and that is R, that is the separation between the two charges. So we get the intensity of the force to be that Hence, F is equal to 1.125 times 10 to the 7 Newton. That gives us the answer C. Question 5, the answer is C. So from the diagram below, you see the diagram. It is seen that since the coil has negligible resistance, the value of the voltage at the end of it is still 4.5 microvolt. So it will not change. So take a look at the diagram and you understand. So that is it. We call this electromagnetism or electromagnetic induction. That is, an EMF is induced due to a change in the flux or magnetic flux of a bar magnet. Question 6. The answer is C. So take a look at the copper wire which is wounded around the conductor, and we have the longitudinal view and we have the cross-sectional view. So the length of the copper wire, which is L, is equal to the number of turns N times the circumference of one circle. You see that it will correspond to it, provided there is no space between each turn. So I will have the length of the copper wire is 314 meters, and the circumference of the circle is equal to 2 pi times the radius of the rod plus the diameter of the copper wire. Hence, 314 is equal to the number of turns N times 2 pi into 5.2 times 10 to the minus 2. So N is equal to all that algebra being equal to 961.5 turns, which is approximately 100 turns. That gives us the answer C. Question 7. Answer is A. A potentiometer is a device used basically to measure the potential difference accurately. The accuracy of a potentiometer. The accuracy depends on 1. The uniformity of the potentiometer wire. That is, if the potentiometer is uniform throughout its length. 2. The uncertainty in determining the balance point. 3. The sensitivity of the galvanometer, in bracket, it is a current measuring instrument. 4. It also depends on the stability of the current. And from all the proposition, we see that all three are correct. So the answer will be A. And you should take note that a potentiometer may lack a balance point if the PD to be measured is connected in a wrong way. That is, the positive terminal of the test cell is connected to the negative terminal of the driver cell, and if the PD to be measured is greater than the PD across the potentiometer. So the two conditions will cause a lack of balance in the potentiometer. So question 8. The answer is C. In optics, the corpuscular character of light states that light is made up of small discrete particles called corpuscles, in bracket little particles, which travel in a straight line with a finite velocity. We can call that velocity the speed of light in a vacuum. Therefore, by the corpuscular character of light, the phenomenon that can explain is refraction, which is a sudden change in the direction of light waves when they pass one optical medium to another. So you see incident corpuscles that leave the less dense medium or the rarer medium and enter the denser medium. They are refracted in the denser medium. So this experiment demonstrates the corpuscular character of light. So it is refraction. So question 9, the answer is E. And you see a thorium particle that disintegrates into a beta particle and a daughter nucleus. So we have thorium that disintegrates into a beta particle and a daughter nucleus which has the formula XYZ. So from the conservation of mass number, we have 234 being equal to 0.x, so x is equal to 234. Also, from the conservation of charge number, we have 90 being equal to minus 1 plus y, so y is equal to 91. Hence, we have the daughter nucleus to be constituted of 91 protons and 143 neutrons. So that's why the answer is E. Question 10. The answer is A. Photoelectric effect is the ejection of electrons from a cold metal surface when a radiation of sufficiently high frequency falls on it, and it is independent of the light output or intensity. What depends on the intensity is the number of photoelectrons emitted per second. So the greater the intensity of the light that falls on the metal surface, the greater the number of photoelectrons emitted per second. And so we have that it depends just on the frequency of the incident light that falls on it. And for any metal, electrons are only emitted if the frequency of the incident light is above some minimal value called the threshold frequency. And the maximum kinetic energy of the electrons emitted depends only on the frequency of the incident radiation and is independent of the intensity of the radiation. The last one is that the photoelectrons are emitted as soon as radiations of sufficiently large frequency falls on the metal surface. That is, there is no time delay between irradiation and emission. Question 11. The answer is B. The threshold frequency depends on the cathode metal and doesn't depend on the anode nor the number of photons arriving the cathode per unit time. Visible light and ultraviolet light affect the frequency and hence will affect the photoelectric current. Below is an experiment to better understand the photoelectric effect. So we have incident light that strike a cathode or the target metals, and this target metal will then release electrons which are captured by the anode. Yes, so the electron flow are captured by the anode, and the anode then passes the electrons to the ammeter, and from the ammeter there's a rheostat and a battery that will be detected, or the ammeter will detect that as current, so demonstrating photoelectric effect in a target metal or cathode. Question 12, our answer is B. We have indium that disintegrates into a positron particle and a daughter nucleus. So we have a positron is a positive beta particle. So we have that equation there which gives us from the conservation of mass number, we have 110 is equal to 0 plus x. Yes, so x is equal to 110. And from the conservation of charge number, we have 49 is equal to 1 plus y, so y is equal to 48. Hence, the daughter nucleus is equal to 110, 48 indium. That's why the answer is B. Question 13, our answer is A. 1 becquerel is equivalent to an activity of 1 disintegration per second. So an activity of 9.5 times 10 to the power 13 becquerel is equivalent to 9.15 times 10 to the 13 disintegrations per second. So yes. Question 14. Our answer is A. So from the equation A equal to A0 e to the minus lambda t, that I'll call equation 1, and from the equation lambda equals to ln 2 all over the half-life of t half, or t half, we have lambda equals to ln 2 divided by 8.04, which is the half-life, will give us 0.0862. So if we take ln on both sides of equation 1, we have ln A being equals to ln A0 minus lambda t. That gives t being equal to ln of A divided by A0 divided by minus lambda. We substitute in our values of A0 and lambda, we get t to be equal to 2.05 days. Question 15. The answer is C. The threshold frequency is the minimum frequency required to eject a photoelectron from a metal surface, and this threshold frequency depends only on the target metal. Question 16. The answer is C. Laplace force, F is given by F equals to IL cross B, while the Lorentz force is given by B equals to B cross QV. Since I, which is the current, originates from the charges in bracket electrons, and B, which is the magnetic field density, originates from the magnetic field that charges when in motion produce, a combination of the two produces an electromagnetic force known as Laplace force. So Laplace force is an electromagnetic force, and from the formula F equals to IL cross B, we see that the force is perpendicular to the current passing through the conductor, the length of the conductor, and the magnetic field strength. So to get the direction of F, or the Laplace force, we make use of Fleming's left hand rule as shown below. So the thumb indicates the direction of the force, the first finger the direction of the magnetic field density, and the second finger indicates the direction of the current. Question 17. Answer is C. So that's the diagram of the moon and the earth. Hence, we are looking for the point where and GM, that is, we are looking for the point where GM is equal to GM times M all over R square, implies that GME divided by RE square is equal to GMM all over RM square. So ME is equal to MM, which is equal to 384 times 10 to the 3 minus x squared divided by x squared. But ME all over MM is equal to 81.5. So 81.5 is equal to that, and we have that algebra giving us x to be equal to 38,293.8 kilometers. So the point of equigravity is at 38,293.8 kilometers away from the moon. Question 18. The answer is A. From Newton's second law, which says that the rate of change of linear momentum is directly proportional to the resultant force applied and takes place in the direction of the resultant force, we have F being equal to ma. So force is equal to mass times acceleration. So the acceleration is given by the force divided by the mass. So A equal to that gives us A equal to 8 meters per second square. Question 19, our answer is simply C. So we have the two balls, one being dropped vertically downward and the other given with an horizontal speed. So the two balls reach the ground at the same time because both will have new vertical velocities. Question 20, answer is D. So we have that our diagram, the ball which is considered as a point mass being projected with a speed v0 at an angle alpha. So after some times it reaches the maximum height h max. So the acceleration that opposes the motion of the ball when it goes up is minus g. At the top of the path, the sign of g changes from negative to positive, causing the particle to accelerate downward. This is because at the top of the path, the acceleration of the object or of the ball is 0. So the correct proposition is D. Question 21, the answer is C. At the top of the path, the horizontal velocity, that is Vx, is equal to V0 cos alpha, is kept constant. Yes, because the horizontal velocity is not affected by gravity, but the vertical velocity is 0, that is Vy equals to 0, since the acceleration is 0. And so V being equals to Vx, the square root of Vx squared plus Vy squared will be minimal, with V being equals to Vx being equal to V0 cos alpha and Vy being equal to 0. So the speed is minimal and it is not null, that is, it is not 0. Take note. Question 22. The answer is D. From the equation of trajectory, we have that so at the top where dy dx is equal to 0, we have h max being equals to v0 squared times sine square alpha divided by 2g. From the formula, we see very well that the maximum height is proportional to the square of v0. So the correct proposition is D. Question 23, the answer is B. From the formula of the time of flight t being equal to 2v0 sine alpha divided by 2g, we see that the duration of the movement of the ball is proportional to v0. Question 24. The answer is C. The gravitational field strength of the star is equal to the gravitational constant times the mass of the star divided by r square. So the radius of the star is equal to the square root of gm the star divided by g. But mass of the star is equal to 2 times the mass of the sun. So the radius of the star will be equal to all that calculation or all those calculations. Yes. And r of the star will be equal to 10,008.79 meters, which is approximately 10 kilometers. So the correct proposition is C. Question 25, which is the last question, we have that our answer is equal to C since G, which is the gravitational field strength, is equal to the gravitational constant times the mass divided by r square or the distance square. Hence, G will be equal to all that algebra. I cannot like say all those figures, so just take a look at it. Hence, G will be equal to 3.3 times 10 to the minus 5 Newton per kilogram. Take note of your unit. Yes, just verify it well. So